Hi everyone, welcome to another video of AppSecEngineer and V45. Now in this video, we'll be talking about DOMPurify and we'll be doing a live coding session on DOMPurify. Before we get into DOMPurify itself, let's talk a little bit about cross-site scripting, right? Now, if you're watching the video, there's a good chance that you know a little bit about cross-site scripting, right? Cross-site scripting is probably been one of the most pernicious security flaws that's been plaguing the web for a very, very long time now. It's been around for a while. In fact, if you're a developer who's had penetration test reports or vulnerability scan reports, you would probably see that cross-site scripting is one of those really tough flaws to fix because there are so many different things that can go wrong with cross-site scripting. Plus, also it doesn't help that a lot of this happens on the browser, so there's really very little you can do in terms of controlling a lot of cross-site scripting, right? However, recently, especially over the last 4 or 5 years, we've seen a lot of new innovations from the browsers, from the security community, from the developer community at large that's been tackling this problem quite comprehensively, be it content security policy or be it trusted types or so on and so forth, or a bunch of libraries out there. They've been really taking on this problem head on. And we're going to be talking about one of those libraries today, which is called DOMPurify. Now, DOMPurify is a library by Cure53 Berlin, which is a really renowned security consulting firm, and I think they do a lot of work and research in the space of JavaScript and client-side security. So let's get started with kind of understanding the problem first, and then looking at a live coding example with DOMPurify. Now, one of the defenses against cross-site scripting is output escaping. Right? Now, output escaping essentially works like this, where whenever output is rendered, especially user-generated output data or user-generated data, whenever it's rendered to the output, like an HTML template or an email or so on and so forth, you would see that it's rendered in multiple contexts. Now, in most cases, the context that it escapes automatically is the HTML entities context. Now, whenever you're using libraries to do escaping, by default, they would typically do the HTML entities context. However, one of the challenges that you will see with cross-site scripting and why it's a little difficult to prevent in many cases is only because developers end up loading user-generated data in multiple contexts, like the CSS context or the JavaScript context or the HTML attribute context. So even if your templating system or React or Vue or whatever system that you're using does escaping, and all of them say auto-escaping. When they do auto-escaping, what they really mean is that they auto-escape HTML entities. Now, escaping essentially is the process of stripping out all these special characters and rendering them as data, which is essentially what prevents cross-site scripting. So cross-site scripting happens when the browser sees all of this as executable code and it executes the JavaScript. So by output escaping, what you're really doing is that you are essentially signaling to the browser that, hey, browser, this is not executable code. This is just user-generated data, and you just have to display it as such. So what output escaping does, especially with the HTML entities context, is it strips out all of these special characters and then renders them as data. So let's look at an example of this. I've just written up a quick application to show you what this looks like. Right? So we have an application here that has this template. So from the server side, which is our app.py, we are rendering all of these variables to the client side. So we have 3 variables. We have the para variable, the anchor variable, and the JS variable. And you look at these 3 variables, they are 3 different types of cross-site scripting payloads. So one is going to be rendered as an HTML entity. One is going to go into an anchor tag. And the last one is going to go into a JavaScript context. They're going to be rendered in 3 different contexts. So if you look at the HTML, you'll see that they're going to be rendered one as an HTML entity, one as an href for an anchor tag, and the last one is going to be rendered as a JavaScript entity whenever I click my mouse on that paragraph. So let's see how this works, and let's see what is the challenge with doing something like this, right? So let's run this app and access this app on our browser. So I'm going to use Firefox for this. So I'm going to just load this app, right? Now here, you'll see that we have three different contexts. The first one is very interesting because you see that the cross-site scripting attack has been rendered completely toothless because it has auto-escaped that data set. So if you look at the page source, you will see that it has auto-escaped this, right? So the template itself has done a great job of auto-escaping the special characters in the payload here. So it's rendered as an HTML entity, so it's escaped those special characters. However, if I use this, so let's say I've rendered this as an anchor tag. If I click on this, you will see that the attack still works because see, it's not escaped. If you look at the code, it looks like so this is a JavaScript URI style payload where I can use JavaScript colon and then a function declaration or whatever JavaScript I want to declare as an href. So it still works because, hey, this is not an entity. And remember, templating systems in most cases only do HTML entities. The last one is even more crazy because if you click on this, you see that it renders the cross-site scripting attack because the variable, remember, is now rendered as in the JavaScript context. So on mouse down, it's going to trigger this JavaScript payload. And that's the fundamental problem with preventing cross-site scripting, right? A lot of times we're not able to do that only because we're rendering data to multiple contexts, and that's why it becomes a little harder to do because we may not be aware of these contexts and the fact that our libraries don't auto-escape them by default. Now, DOMPurify is an interesting project from the Cure 53 team, and this project is essentially an HTML sanitizer. Right now, this sanitizer, they have some very clearly mapped out goals and threat models for this project. I would highly recommend you look at that. It's been well maintained for a really long time now. So these are the security goals and threat models. Of course, one of their main goals is to be fast and be simple, just make it easy for developers to use. And I think they've succeeded wildly in doing that. So it's really good, very easy to use. It's an HTML sanitizer. It really works well when you're dealing with standard JavaScript libraries or jQuery and stuff like that. But when you kind of go into React or Vue.js or Angular, that's when things might hit a little bit of a challenge for you. So you probably need to look at different approaches when doing that. I think you can still do it with these frameworks, but don't expect that all of this will be easily sanitized because a lot of this is based on virtual DOM and so on and so forth, which may be a little difficult to work with. But if you are working with jQuery or other JavaScript libraries in the front end, then it's definitely worthwhile considering this project. Again, right? So you do have some goals and threat models that you should definitely be looking at. It does have some specific limitations. Like it says, it's not going to protect you against CSS based attacks. So if you're loading stuff in a CSS context, DOMPurify is not exactly the library that you should use, right? So, or, bad use of markup context and so on and so forth. That's one of the things you might have challenge with DOMPurify. So let's look at using DOMPurify in our app and trying to see whether we can actually harden our app, our existing application, with the DOMPurify library, right? So let's get started with this. So I'm going to make a few changes to my application. I'm going to add DOMPurify as a script. Now I'm going to just source it from CDN.js. I think it has a CDN.js. CDN. Oh yeah, it looks like we've already referred to it once before. I'm going to copy the minimized or minified version of DOMPurify for my example, right? And the next thing I'm going to do is I am going to write some JavaScript code that will filter this stuff out, right? So the first thing I will do is remove this. We'll add this in later when we need to. Or actually, let's just do it with this, right? We'll do it all at the same time. So the first thing I'm going to do is I'm going to add filter for the anchor href, right? This is the first thing I'm going to do. And this is the filter I'm going to write. So I'm going to initialize, so I'm going to get the variable here. Now I'm going to remove this particular tag and I'm going to rewrite this from JavaScript on the DOM. So I'm going to actually remove this tag here and I'm going to frame it completely differently. So I'm going to take the dirty href from our server-side variable. So this is going to be our anchor underscore variable. Remember, this was what is being rendered from the server side. So whatever is in this server side's anchor variable is going to be rendered on the client side. So in this case, the anchor variable happens to be JavaScript :alert1. So this is the variable that I'm just going to render from my template. The next thing I'm going to do is I'm going to create a anchor tag. So I'm going to call this link, and I'm going to say document.create element. I'm going to use the anchor element, and here I'm going to set an attribute. So link.set attribute. I'm going to use the href attribute, and I'm going to set it to the dirty href, right? So I'm going to just semicolon close all of this stuff, set that. So what it's going to do is essentially going to create an anchor tag, set it to the href value of whatever comes in this variable, right? So whatever comes into this particular variable or whatever is resolved from this variable is going to be in the anchor href. I'm also going to add some inner text value, which is going to be click me if you want to live, right? So I'm going to add that, and I'm then going to process this through DOMPurify. So the first thing I'm going to do is say var clean link, which is going to be my clean link. So post sanitization, my link is going to be this, right? So I'm going to use DOMPurify .sanitize, and this is a very simple thing you can do. Just call the sanitize call with your dirty HTML markup, and it will try and sanitize that for you, which is really, really nice. So what I'm doing in this case is I'm taking the entire DOM element in this case, passing it into DOMPurify to say that, hey, here's the entire element, here is the the markup, figure it out and tell me what to sanitize, right? So I'm just passing the entire thing. I'm just going to take the link and I'm going to use this in place. So in place is essentially just an option that DOMPurify provides to take the entire element or any segment of the markup and pass it entirely to DOMPurify. You can do this for HTMLs, or you can do this for the entire one aspect of the document object model. You can do that for the entire document. So I'm just doing this for this particular element, which is going to say in place true. So I'm just going to call DOMPurify to sanitize, and I'm also going to console.log. So once we clean it up, right, we want to see what it looks like on the console. So I'm just going to say cleaned markup looks is, and then I'm going to add concatenate the clean link here, and finally I'm going to render this on screen. So document.body.append child, I'm going to add the clean link. So this is going to just add this on my document object model. So I'm going to do the same thing for my paragraph, right? So in this case, you see that on mouse down, I had this JavaScript variable, and this JavaScript variable happened to be this, right, alert1, which is obviously not good because it was not, we didn't have any way of sanitizing the JavaScript context. So here what I'm going to do is I'm going to add another scenario saying var dirty JS, and I'm going to include my JS variable. Now this JS variable is going to resolve from the variable on the server side. So we have a JS variable called this, and when it passes to the template, it's going to be called JS variable. So I'm just going to render this template variable here. I'm also going to create a para and call it document.create element p. Now para.set attribute on mouse down, and we're going to add our dirty JS, right? So this is going to be rendered on mouse down. So whenever a paragraph loads on mouse down, this is what's going to be rendered, or at least that's what the attacker is hoping will render, right? So the attacker is trying to influence this. So the attacker controls these variables from the server side. The attacker is going to try and load this on the client side. Hopefully with DOMPurify, we'll see that this does not work. I'm also going to set some inner text for this. I am a paragraph. Click on me. So I'm just adding some data to the paragraph, and I'm going to also now start to purify this. Clean para is going to be DOMPurify dot sanitize, and I'm going to do the same thing, except that I'm going to take the entire paragraph, the paragraph element, and I'm going to run it in place, run it as true. Yeah, I'm just going to add some console.log. I'm just going to copy this and just going to paste this in and make a few changes to the variables. Clean para here and here, right? So I'm going to append child paragraph. Now let's see what happens when I do this. Now remember, I am passing all of this. So we already have, I'm not bothered about the para variable because remember, it's already sanitized. It's already taken care of by my templating system. Unless I turn off the sanitization, it's not going to fail on me. However, I'm going to remove this and both these things. So we're going to render an anchor tag and a paragraph tag on our body, and this is going to be rendered through DOMPurify. So it's essentially going to contextually escape or sanitize all of this data. Not really escape, it's going to really try and sanitize and find some dangerous elements in there, and it's going to try and remove it. It's going to strip it out and just give you a hopefully clean definition, hopefully clean markup, right? Now what we're going to do is we're going to reload our app. We don't actually need to do this, but I'm just going to do this in case. We're going to open up Firefox, and we're going to also open up our web developer and look at our console. Okay. Now this is where we should see some interesting information. Now the first thing I'm going to do is reload the page, and you will see that the clean markup has been set to, so you'll see that the markup has actually been cleaned out, right? So if I click on this, you'll see that nothing works because DOMPurify has completely stripped it out. What was dangerous markup has now been completely stripped down to very, very clean markup. And the same thing has happened with the anchor tag as well. If I click on this, obviously nothing works because it saw that, hey, this anchor tag happened to be something dangerous like JavaScript alert1, and this JavaScript variable happened to be alert1. So DOMPurify has been able to identify this contextually and strip it out. I'm actually going to just log this because I think it's easier to log this rather than concatenate it. You'll see actually what's happening. And I'm going to reload the page. So if I reload the page, you will see that the anchor tag is created, but it's not really doing anything. It does not even have that href. In fact, you see that the href is set to 0 because it stripped out the dangerous JavaScript. As a result, there is no href. It just stripped it out. It just rendered as data, rendering an attacker's attempt at trying to do cross-site scripting against your application completely toothless. And the same thing with the para p tag as well, right? So if you look at the p tag, you will see that we were supposed to have an on mouse down, but I don't think we're going to have it. On mouse down is set to null because again it stripped out the dangerous JavaScript. So DOMPurify, I really like DOMPurify because it's simple. It just reduces the sanitize call to a single function call. You do have a bunch of options that you can either allow or deny stuff. So for instance, you can do things like, hey, I want to allow, so let's say you have some kind of a markup that you still want to allow users to do. You want to allow users to use bold or italics or stuff like that. You can have them use the allowed tags. You can also render it safe for templates, which is not ideal, but you can do that if you'd like. You can set up all of these different types of parameters here. You can forbid tags, you can add tags, you can allow. So a lot of times when you are populating hrefs, you might want to populate them. So for instance, in this case, we were populating an href with the JavaScript URI, right? JavaScript URI. You might have other URIs like FTP or HTTP or HTTPS. So let's say you only want to allow specific types of URI parameters. You can allow that in the URI regular expressions, or you can say unknown protocols you can set to allow or deny and so on and so forth. So you really have a lot of ways in which you can set up DOMPurify and parameterize it to a large extent. And you can even do it for the entire document, although you need to be a little careful about that, right? And it's also supported, currently supports the trusted type definition. I'm going to do another video on the trusted type definition a little bit later, but it has some very interesting new features to support the trusted type definition. Now, one of the things I want to just say before we close, DOMPurify is great because it allows you to handle even complex contexts like JavaScript context and HTML attributes and so on and so forth, which other escaping tools do not allow you to do. So instead of escaping it, the idea of DOMPurify, I think, I've not looked at the code extensively, but from what I understand, it uses some kind of context-based sanitization in order to determine whether this is clean or not clean markup. So in our case, if you see, what it's allowed you to do is we have tried to load some dangerous stuff in here, and it's essentially cleaned up that markup before it's rendered it as an output, thereby ensuring that cross-site scripting is completely prevented. So while it may not be perfect, I'm sure there are still some use cases that could be passed through DOMPurify, especially around, I think I tried something around the in-place. Without the in-place, I think it's still rendered, but you will see that DOMPurify really works when you want to sanitize your HTML, make sure that your users are not vulnerable to cross-site scripting. It still does not support CSS context, but it still supports a much wider variety of contexts and scenarios than your typical output escaping libraries do. So I really like DOMPurify, and I think you should definitely have a look at it if you are building apps and you want to prevent against cross-site scripting. It also has stuff like hooks that you can do. You can trigger events based on post-sanitization, pre-sanitization, and so on and so forth. It's pretty interesting what you can do with DOMPurify. So with that, we come to the end of our video. I'd like to thank you for spending your time watching this video. I hope you've gained something out of this. All of the description and the code is going to be in the show notes below in YouTube, and you can check it out. And write to us if you have any questions on DOMPurify. Thank you.